Hello everyone and welcome to this episode of our DirectX 12 beginner tutorial series where we go through the process of building a DirectX 12 application from scratch in C++. Last episode we did some resource allocation on the GPU. We talked a bit about which kind of resource allocations were accessible by the CPU and which were mostly CPU, rather GPU sided. And I talked a bit about in the stream before this episode that actually this part of the method could be a part of the wrapper for each resource. You could store the pointer internally and only unmap when the resource gets released. But we will do that in the future. It's not that big of a change. Today I want to focus on the more, what do you call it, intricate stuff of the DirectX 12 pipeline. It's a fundamental aspect of graphics programming that you might know from other languages, which include shaders, and a, um, it all revolves around how to do data processing on the GPU. We're going to talk about pipeline states and root signatures and shaders. So if we look up the DirectX 12 pipeline, you can see that there is a fine diagram here. We have our pipeline here, which has an input stage and an output stage. The pipeline is what generally happens to your data on the GPU. So it takes in usually vertex buffers and index buffers as a means of uploading data or storing data for the GPU to do operations on. Depending on your pipeline setup, the data will go through different data processing steps. It will always go through an input assembler, and usually it will go through a vertex shader. I say usually, I think it would happen almost always. The only thing I can think of where you don't necessarily use a vertex shader is if you have a entirely different setup than a graphics pipeline. Anyway, the data comes into the pipeline. It gets assembled as an input. It gets processed in the vertex shader, and then there are optional stages along the whole process. We could, along the way, do vertex processing and simply output the data without doing any further calculations, or it could be passed along the pipeline if you have the stages for it to do rasterization and pixel shading, and then some output merging. The output merging is bidirectionally linked to the render target and the depth stencil. The render target is what we saw during a previous episode where we simply link whatever output we have to something in the swap chain, a resource in the swap chain, and we can output that and eventually present it to the screen. We can also write to a depth and stencil buffer. These are two separate objects. The depth buffer is a buffer that contains the depth of each pixel that you have computed in your pixel shader. It also controls whether you could overwrite that certain pixel. You could only overwrite that if the pixel in pixel was closer to the screen / camera than the existing pixel. The thing is that we usually have information up here that is in 3D space, at least for 3D graphics. It might be in 2D space, then nothing really changes in that regard. But down here we will always have a, or I say always, not necessarily, but usually we would have a 2D space output with a 3D component in terms of the depth. This means that a certain transformation goes on, and yeah, the depth itself gets kind of like split off into a separate buffer where it's used to handle draw calls and object overlaps. Yeah, there are different custom shaders that do different things. I think it's out of this scope, at least for now, to talk a bit about those different shaders. We might revisit it in the future. But you might be wondering, well, if I only input vertices or indices for those vertices into the pipeline, how do I use a texture? How do I do different mathematical operations? And each pipeline has sort of an input layout that is related to not only the vertices or indices, but also a separate input layout that relates to other data structures. So you can, in those input slots, which is called root arguments, define several other resources that should be available to the pipeline at different stages to do its computations. You could have constants that you want to be defined for a specific pipeline. You could have descriptors, meaning that you could have certain buffers that were already defined as an argument for this pipeline. Usually that is called something like constant buffers, structured buffers, fixed byte arrays, or whatever we want to call them. In Vulkan, they are probably called uniforms, if I remember correctly. So yeah, we could define that as an input to the pipeline. We could also define tables of several resources stemming from a descriptor heap. We saw a descriptor heap in terms of the swap chain, where the swap chain had its render target view descriptor heap. It was basically a table over references to the render target views with CPU and actually GPU addresses. We only needed the CPU addresses, so therefore we only use those. But you could also do other resources allocated by to tables in terms of their addresses in memory. For instance, you could do shader resource views. That is usually something that is defined as a resource that the shader uses. It could be a texture. It could be a 3D texture. It could be basically a lot of things. It could also be an output from another part of a pipeline or a previous pipeline state. It could also be a series of constant buffers. Constant buffers are basically buffers of numbers, information that you want to use in your pipeline. But constant buffers are buffers that are optimized for very rapid computations. So you could define a lot of different buffers and put their memory address in a table which would reside in a heap, also called a descriptor heap. So you could bind all these things to a pipeline besides the vertices and indices. You can actually also bind so-called static samplers. They handle texture sampling and help the pixel shader out in terms of which pixels to draw. Maybe you want to draw a texture on a certain object after it has been rasterized or changed into 2D screen space. And these samplers help you do that. They also handle upsampling and downsampling and so forth. Static samplers are basically a predefined set of samplers that are available to the whole pipeline. Yeah. So, as I've mentioned, we do not only need the buffers themselves with the vertices and indices, we also need some kind of input description in terms of what other data structures are supposed to flow into this pipeline and handle control of those. So we need to input specifications. We also need to define the actual pipeline itself. What is it supposed to do? And then there is even more to it. You can see here a compute pipeline is differently structured. It doesn't have any of these stages here. But actually, these parts of the pipeline, those that are defined as shader stages, and not fixed function units, but either teal or light blue, maybe light teal color, are all shader programs, which means that they are programmable. Who would have thought, right? So we can't just create the pipeline and set up its inputs. We also need to do some programs that handle the behavior of each of these shaders. We will only do the vertex shader and the pixel shader since it's not needed to do the other shaders for basic rendering. But of course, there are different functionality in the other stages. So yeah, excuse me. You could use them down the line. So right now we have an outline that is related to what we want to do in this episode. Hopefully we will get done doing it all, but we will see. We want to create shader programs. We want to set up 2 input layouts, one for vertex index buffers, plus one for data structures needed for the pipeline, and actually for specific use inside our shader programs. And then we need to set up the actual pipeline. Hello and welcome. We will do one series of pipeline. Many advanced renderers will have several pipelines and do several different things during one frame, but yeah, we will do everything related to the pipeline, I hope, during the episode before I have to go. So that's the overall plan. So I just talked for maybe, let's see, 15 minutes about what we're gonna do today. And we will basically create shader programs, set up our 2 input layouts. One is called the root signature and one is called the specific input layout for the pipeline, and then we will set up an actual pipeline, and then hopefully we will be able to do a draw call. So we will create a wrapper for the shaders themselves and their compilations. As any other program, you need to do compilations in terms of actually being able to use the program. It has to be turned into bytecode that can be run on the GPU. And we will create the actual shaders slash programs themselves. And down here, we will do the pipeline input state, and we would do the root signature. And here we will simply set parameters and bind everything together. We will, of course, create a wrapper which will set the parameters, and then create the functionality that couples everything into a complete pipeline. We will see if I will be able to make the actual draw calls today. Hopefully we will be able to. It would be nice if it were to pan out that way. I think I'll segment this as a separate video and start on the actual code in terms of the shader, which we will start doing. In the next episode. So I'll end the video here. I'll yeah, be doing more code in the next video. Hopefully I explained a bit about the graphics pipeline itself so that it makes sort of sense what we're trying to do. All right, hopefully I'll see you in the next episode.